Okay, so again, besides dealing with differential equations, being able to either A, anti-differentiate, use the initial condition to find C, and then plug in the actual number into the y. Okay, we can also write it as an area function. Okay, we know that the initial conditions x value is here. We're going to add the initial conditions y value here, and that gives us a nice integral function that we can just plug in whatever x is in question and do the math with the calculator. So again, if it's on the calculator part, method 2 is clearly better. Alright, let's look at the next group. It says in 4 through 10, it says use the fundamental theorem in your calculator. Well, ultimately, this is going to be an example where method 2 is the only one that's going to work, because what are we going to see when we have cosine of x cubed? Are we going to be able to anti-differentiate that? No. If we tried to use u substitution, we'd have x cubed as our u. We'd have 3x squared as our dx, or du. 3x squared dx would be our du. And there is no 3x, there is no x squared in this problem, so therefore we would not be able to use substitution. Okay, so if we can't use substitution, then we only have one choice. And again, our x, our initial condition is 0. So we start with 0 to t, cosine x cubed dx plus 2 on the end. And that ultimately would give us a function for f, if you will. And if we put a 1 in there, we can use our calculator and we can come up with the right answer here. Okay. Alright, in a few minutes I'll give you the right answers here, so when you do your setups you can check your answers if you did these already, or if you haven't, I suggest that you do. Let's look at the other ones here. Obviously 5 is exactly the same as that one, except we'll use 5 as our lower limit and plus 1 out of the end. On 6, it says we've got a particle moving along the x-axis. It's given position as x. The velocity is given here at time 6. The particle's position is 4, 0. Okay? And the position of the particle at the time is 7. So again, ultimately we know that there's a couple ways to think about this too. If we know velocity here, if we just did the integral, we would get displacement. True? And then we want to know the particle's position at time 7. So whatever we get for our displacement, we'd have to add it to 4, because 4 is our current position. Alright, same deal here with, again, these seemingly unrelated problems are handled essentially the same way every time. This time they gave us an f function that represents the bacteria population. There's 4 million at time 0. After t hours, the population is growing at a rate of 2t million bacteria per hour. Find the total increase in bacteria for the first 3 hours, and find the total population. Well, again, the total increase is just going to be the area under this curve from 0 to 3, right? It's going 3 hours, right? So the total increase would be that, and then the actual population would be the increase plus what? Plus the 4 million. Same deal here, got another velocity equation, got an initial position, determine the position at time 3. Again, the area under that curve is going to give us the displacement, and we can add the displacement to our current position, which is 5, and that'll give us our final position. So as I mentioned, I'll read the answers here to you, so if you haven't tried those yet, or if you did try them, you can check yours as we go, otherwise check them when you do them. But they should be the following, so here they go. Number 1 and 2 are, again, work problems. Number 2's answer should be 3.5. Check that one, should be 3.5 for this one. Number 3's answer should be 357.36 gallons. 357.36. Number 4 should be 2.932. 5 should be 0.0, or just not 0.0, just 0.996. So 5 should be 0.996. 6 should be 3.837. 7 should be, the first question was the increase. The increase should be 10.099 million. And of course, if we add that to 4, then the final answer should be 14.099 million. And the number 8 should be 6.151. Anything need to be repeated? 6 should be 3.837. And then we had 2 other questions that were, again, almost identical to the other ones that we've dealt with here for 9 and 10. So these, again, are the same concept. I'll give you the answers to those for when you do them, or if you have already done them. Number 9 should get 6.238. Number 10 should be letter D, 5.376. Alright, and let's take a look at the next group here, the 11 through 13 group. It says the graph of the derivative is shown here. So we have a graph of the derivative. Okay, we know that the area from 1 to 4 is 6.2. Okay, so that area under this curve right here is 6.2. So that area shown, 6.2. We know that the f value at 3, the initial value at 1 is 3. And our question is, what's the answer to f of 4? Well, right here, keep in mind that that right there is the area under the curve from 1 to 4. So if we want f of 4, okay, we just take our initial condition and add 6.2 to it. So wouldn't the answer simply be 9.2? You got to think about why. If we didn't know this function, okay, an answer to, or a function for it would be from 1 to t of f prime of x dx plus 3. Based on our initial condition, it would be this here and the 3 here. True? If we had to write the actual function, it would be this. And so bottom line here is if we wanted f of 4, we'd put a 4 in here. And isn't that right there with a 4? Isn't that this? And so what do we get for this? This is 6.2 and this is 3. 6.2 plus 3 is 9.2. And you can do the same thing on number 12. The only problem is this time they didn't give you the area, so what are you going to need to do? Recognize that it's a half circle and calculate its area. So ultimately it's going to be, it's got 4, so it's going to be 16 pi, but it's half of that, so 8 pi. So 8 pi plus the initial 7 here was our initial amount, right? F of 4 is 7. Now remember that here we have f of 4 and we're going to f of negative 4. So keep in mind, if we were to write the integral here, we go 4, we go t, we go f prime here, dx, and then we go plus 7 out here if we were to write it as such. And if we put a negative 4 in here, then that area part's going to give us not 8 pi, but what? Negative 8 pi. So the answer is actually negative 8 pi plus 7, isn't it? Okay. And the reason is because, again, we knew the f of 4, we're going backwards to f of negative 4. And the final one here on worksheet 5, similarly to what we had here, I'll read you the answers. If we do the same concept, finding these values, A should have been 9.5, B should be 6.5, and C should be 6.5 plus 2 pi. It should be 1 unless it says otherwise. That's why this has a radius of 2, so the circle would be 2 squared times pi would be 4 pi, but it's only a half circle, so therefore it would be 2 pi. And the rest we're just finding areas of these triangles. Okay. Alright, I believe that's the end of that one, right? Okay. We'll go ahead and stop for